Assalamu alaikum. The topic of today's video is Schrodinger wave equation. In this video, we will derive complete Schrodinger wave equation. We will also describe the applications of Schrodinger wave equation and the history and everything we will discuss in this video lecture. So moving on. In 1926, an Austrian physicist named Erwin Schrödinger developed the wave mechanical model of atom. Do you know what is the wave mechanical model of atom? According to the wave mechanical model of atom, the nucleus can be considered as a particle, as a positively charged particles, and whereas the electron is considered to be a stationary wave around the nucleus. Okay, according to wave mechanical model, the nucleus is a particle present at the center and the electron is considered to be a wave around the nucleus. Moving on, this theory, the wave mechanical model, takes into account the wave and particle nature of electron. This equation, this Schrodinger wave equation, this takes into account the wave and particle nature of electron. Now the Schrodinger, he visualized the atom as a positively charged nucleus. Okay, he visualized the atom as positively charged nucleus, as a positively charged nucleus surrounded by standing electron waves, surrounded by stationary electron wave which extends round the nucleus, Okay, if the electron has wave like nature, if we say that the electron is having a wave like nature, it would obey the same equation of motion as all the other known types of waves obey. So if we are taking the electron to be a wave, if we are taking the electron as a wave, so it is possible that it would follow all the laws that are obeyed by the waves. Moving on, the Schrodinger gave his famous Schrodinger wave equation to describe the wave motion of an electron along any of the three x, y or z axes. So Schrodinger described the wave motion of an electron in the x, y or z axis. So how did he do that? We will move on. First of all, consider a particle P moving in a circle. I am drawing a circle. This is a circle, and this is a circular path along which the particle P. If I consider this is a particle P, then I'll say that particle P is moving in a circle. Secondly, this is the mean position. I have drawn mean position, and let me draw another line for the y-axis. So this is the y-axis, this is the y-axis, and this is the x-axis. The radius of the particle P, I can describe the radius of particle P as A. I have denoted the radius of particle P as A. And now moving on, if I say that the vertical distance covered by the particle is psi, I have given the name psi to the vertical distance covered by the particle. The particle is moving in a circle, okay, and if I say that in a given time the particle P has moved an angle theta from its mean position to some place, and during its movement it has covered a vertical distance of psi, okay, and it is moving in a circle of radius a. So if I plot this in the form of a wave, let me plot this in the form of a wave. So when the particle moved from the position, from zero position to its maximum, so I can plot a wave accordingly as like this, okay, and then the particle came back to its original position, to the zero line. So the particle came back to its zero line here, and then the particle covered a distance downwards. So I can say that the wave has covered the distance in the downward direction, and when this particle reached here, I can say that the wave has reached here. So it is just the representation of the motion of particle in the form of a wave. So now, as you know that sine theta is equal to perpendicular over hypotenuse, okay, in this triangle the perpendicular is psi and the hypotenuse is a, okay. So if I say that sine theta is equal to perpendicular over hypotenuse, so now I'm putting the value, the perpendicular is psi, so I put psi here, the hypotenuse is a, so I put a here, and I can say that sine theta is equal to psi over a, and if a multiplies here, I can say that psi is equal to a sine theta. So I have got the value of psi as psi is equal to a sine theta, and you know that theta is equal to omega t. Theta is equal to omega t, and omega has a value of 2 multiply pi multiply frequency multiply by time. So I can say that 2 multiply pi multiply frequency multiply time is equal to theta, because omega has the value of 2 pi f. So we can say that theta is equal to 2 pi f t. So putting the value of the theta in this equation, I get psi is equal to a sine 2 pi f t. So this is the value of psi. So now you know the distance formula. The distance formula is x is equal to vt, where x is the distance, v is the velocity, and t is the time. You know the distance formula, x is equal to vt. From here we are going to find the value of t, time. So if we are going to find the value of time, the v will come here and will divide by x. Okay, so the t value, if we evaluate the t value from here, v will come here. So x divided by v is equal to t. So this is the value of t which I am going to put here in this equation. Okay, so the equation becomes psi is equal to a sine 2 pi f, and this becomes x over v. So I have just put x over v in the place of t. So what is next? You know the formula, v is equal to frequency multiply lambda. That is very famous formula, and you have heard about it before, that v is equal to the velocity is equal to frequency multiply lambda. So here we are going to find the value of frequency. So if I want to find the value of frequency, lambda will divide here, so f will be equal to v over lambda. So this value of f is I am going to put here. Okay, so put the value of f here, and it will become psi is equal to a sine 2 pi, and in place of f I am going to write v over lambda. This is x and this is the previous v. This v will cut down with this v, and the equation becomes a sine 2 pi x over lambda. So this is the equation which I have derived from starting sine theta, from the start point of the sine theta. So I have got the value of psi is equal to a sine 2 pi x over lambda. So if we differentiate this equation with respect to x, we get I'm going to differentiate this equation with respect to x. So first of all, I'm writing the same equation here. Psi is equal to a sine 2 pi x divided by lambda. Now I am going to differentiate this equation. So if I differentiate this equation with respect to x, so it will become d psi over dx is equal to a cos 2 pi x over lambda, and the extra thing that will come here will be 2 pi over lambda. Okay, so this is what we have differentiated with respect to x. So on differentiation with respect to x, it becomes d psi divided by dx is equal to sine has a differentiation, sine has a derivative of cos, so sine become cos, and this is the extra factor that is included. So this is the extra factor that has come from the derivation. So on differentiating with respect to x, the equation becomes just like this, and I'm going to just rearrange the equation. 2 pi over lambda will come earlier, and this I have written later. So I am going to differentiate this equation again with respect to x, and it will become d square psi divided by dx square, because I have differentiated this equation again with respect to x, so it will become dx square, and it will become d square psi is equal to, and this is 2 pi a divided by lambda, it is the same. The next thing, cos, the cos changes into minus sign on differentiating. Again the cos changes into minus sign. The 2 pi x over lambda is same, 2 pi x over lambda is same here, and the second thing, that is another extra factor that was added before, will add again 2 pi divided by lambda. This is the extra factor that is being added. Okay, so this 2 pi will multiply with this 2 pi, and it will become 4 pi square. The equation will become 4 pi square A divided by lambda into lambda square, and this minus I have written here, and the rest of the equation becomes A sine 2 pi x over lambda. So A sine 2 pi x over lambda, what was this? The A sine 2 pi x over lambda was equal to psi. Here I have taken A sine 2 pi x over lambda is equal to psi. So I am just going to put the value here. So the equation becomes d square psi divided by dx square is equal to minus 4 pi square. This term here is equal to psi, so I have placed psi in place of this term. Okay, rest of the equation is just the same. D square psi divided by dx square is equal to minus 4 pi square a by lambda square psi. So if I take this term on the other side of the equality sign, this minus will change into positive sign. Okay, so this is the equality sign, this is the left side of the equation, this is the right hand side of the equation. So if I want to take this side on towards the left hand side of the equation, it will be just like that. This part has come here. Okay, so this become plus and is equal to 0. So this is the classical wave. This is the classical wave equation, okay, that describes the wave motion of any particle along the x-axis. Okay, because I have taken only the x-axis, I am not talking about the 3 dimensions, I am only talking about the motion of a particle in one direction only in along x-axis. So this is the classical wave equation that describes the wave motion of any particle along x-axis. Since the electron, since we are talking about the electron is proved to have a wave character. Okay, the electron is proved to have a wave character. So let us assume the same behavior. Okay, so assuming the same behavior, if we want to apply this equation, if we want to apply this classical wave equation, this lambda must be replaced by the momentum of the particle. So how can I replace this lambda with the momentum of a particle? Well, you have read about Broglie hypothesis, Broglie principle, that lambda is equal to h over mb. According to Broglie, lambda is equal to h over mb. This was Broglie's principle. So we are making the use of this same principle, just like that. So taking square on both sides. Why I have taken the square? Because the equation right here, there was lambda square in the denominator, and I want to put the value of lambda square here. So I have taken the square, lambda square, and it will become equal to h square divided by mv square. I have taken the reciprocal. On taking the reciprocal, the h square and mv square, they have changed the positions. So this is the reciprocal. On putting so I have to put this lambda square back into the equation. This was the same equation that I had derived before. This is the same equation that I have written here. So on finding the value of 1 over lambda square, I am just gonna put this 1 over lambda square's value, this value here. So the equation becomes d square psi divided by dx square plus 4 pi square psi, and the thing that I have included is m square v square divided by h square is equal to 0. So this is the equation that have come after putting the value of lambda square. And moving on, if the total energy, you know what is the total energy? The total energy of a particle is equal to its kinetic energy plus the potential energy. Okay, so you know that the kinetic energy has a value half mv square, and potential energy, if I represent potential energy with v, so it will become plus v, and total energy I have represent total energy with e. Okay, plus v, after coming here will become minus v, so half mv square will be equal to e minus v. Okay, so if 2 is in the denominator here, and it will come here to multiply, so it will become 2 into e minus v. This v represents the potential energy. Next thing, I have to find the value of v square, so m will divide here. V square is equal to 2 into e minus v divided by m. So this becomes the value of v square, and I am gonna put this value of v square here. Okay, I'm gonna put this value of v square back in this equation. So First of all, I'm writing the equation again. D square psi divided by dx square plus 4 pi square. This is the psi. This psi sign I'm going to use at the end. So I'm not going to put this psi sign here. I'm just gonna move on with m square and divided by h square. This v square, what is the value of this v square? This v square has a value of 2 into e minus v divided by m. So multiply by 2, I am taking 2 here, and the e minus v, okay, divided by m, and I have left the psi, so I will write the psi here is equal to 0. This m will cut with 1 m, okay, and 4 to the 8, so this becomes d square psi divided by dx square plus 4 to the 8 pi square m e minus v divided by h square psi is equal to 0. So this is the wave equation when the particle is moving in one dimensional system. This is the wave equation when the particle is moving in one dimensional system. That is, the wave is moving only in the direction, only in one direction. The wave is only moving in the direction of x. So for the electrons which can have their motion along x, y and z axis, we can similarly write this equation as curly square psi divided by curly x square plus curly square psi divided by curly y square plus curly square psi divided by curly z square plus 8 pi square m divided by h square into e minus v psi is equal to 0. So this is the wave equation, or simply I can write it as, if I take psi as common, psi and psi, if I take psi as common, the remaining part of the equation is lambda, is called delta square, del squared, and del square, and I have taken the psi as common, so here's the psi, and the remaining equation is a plus 8 pi square m divided by h square e minus v psi is equal to 0. So this here, this part here is equal to this del square is equal to curly square divided by curly x square plus curly square divided by curly y square plus curly square divided by curly z square. So this del squared is equal to this value, and it is multiplied by psi. So moving on, the equation can be written as, if I take this part of the equation towards the other side, towards the right hand side, the equation becomes del squared psi is equal to minus 8 pi square m e minus v divided by h square psi. Okay, so I have just moved this part of the equation towards the right hand side. The next thing, I am gonna multiply this whole part of the equation with e and v. So let's see what would become. I'm gonna write that part of the equation again. Del squared psi is equal to minus 8 pi square m divided by h square e minus v into psi. So I am going to multiply this with this all of the equation with e and v. So on multiplying, the equation becomes just like that. Since this minus and this minus is considered, minus minus plus, and here I have put e and here it is v. Okay, so the equation becomes just like this. The next thing, multiplying the equation on both sides by h square over 8 pi square m, or in other words, I can say that I am going to take 8 pi square m divided by h square as common. The equation becomes minus 8 pi square m divided by h square as common. The equation becomes e psi plus minus since I've taken minus also is common, so E psi minus V psi. Okay, the equation becomes just like that. And now this part h square, since it is in the denominator, it will multiply here and it will come in the denominator. So moving on. This will be equal to minus E psi minus minus plus V psi. Okay, so this will be equal to minus E psi plus V psi, and the next thing that we are going to do is I'm going to find the value of E psi. The E psi will come here and this part of equation will go here. So E psi will be equal to minus h square del squared psi divided by 8 pi square m plus V psi. Okay, the next thing that I'm going to do is taking psi as common. Minus h square del square psi del square divided by 8 pi square m plus V, taking common psi. Here it is E psi. This part of equation can be taken equal to h, the Hamiltonian operator. So the equation becomes E psi is equal to h psi. This h here is known as the Hamiltonian operator, and it represents certain way of expressing the total energy of a system. It represents a certain way of expressing the total energy of system, and E is the numerical value of the energy. The E here is the numerical value of energy, and h here is the Hamiltonian operator. Okay, so this was the Schrodinger wave equation. This was the wave equation that was used, that was derived by Schrodinger to explain the wave mechanical model of the atom.